thanks to all for still being present. The last presentation I made quite some time ago was in the US, and after the third day there was nobody left. And I had also the second last presentation, and then there was a fire alarm, and then there was nobody left. So CIQ, Computer Integrated Quality. So it's our quality data management system. It's one of the products that we distribute or that we produce in our company. Maybe just a few words about the company AESA I'm working for. So it's the origin of the company. It's a Swiss company. It's a company which was started in a cable factory, AESA Cablerie de Cortaillot, in Cortaillot. And in fact, they needed test instruments. They were not available, so they decided to design their own instruments. And then later on, they started selling even some of them. And in '97, Nexans bought the company, and they said, we make cables, we don't make any test instruments. Please do your business somewhere else. And there was a management buyout, and let's say the company is independent since then. So what is our mission? Our mission is really to enhance quality management, so to produce tools in order to check the quality, check the quality, have data, everything which is now needed. We have heard these 2 days about the food for the AI. We need data. So we are generating this data and we're managing this data. So what type of services and products we supply? So mainly our business is test instruments. So we are testing energy conductors, so power cables. We are testing mainly the linear resistance on those cables. We are checking how big is the pipe that can, the amount of energy that can be transferred, let's call it like that. Then we have communication cables. We are testing all type of electrical transmission parameters. Then we have our CIQ software, our quality data management system that we are going to talk about, which was also developed in a cable factory because about 15 years ago, AESA acquired one company in Germany called MEA, and they had their own software, which was developed within a cable factory, maybe for some of who are from Germany, ERP. So that company developed a certain software. It was taken over by MEA that time, and now it's integrated within our products. So when there was the merger, the decision was taken that the software is made in Germany and the hardware is made in Switzerland. So we have 2 locations, one in Germany, one in Switzerland, and we have also some offices in China. Besides, of course, we have services, calibration services, testing, certification, and so on. So what is so specific about quality data management for the cable industry? In fact, there are a lot of softwares who can provide these type of tools. But as it was mentioned several times, our industry needs something specific. And so in order really to give value to data, you have to standardize it, to format it so that it can be compared, that it can be used. It has to be centralized somewhere so that it's available for everybody. And yeah, you have to use then this data in order to make evaluation, to have efficient KPIs in order to drive production, to drive quality, and drive your production process. And in the end, also improve your profitability, because the tighter your tolerances, less scrap, and less raw material usage. So that means money in the end. So what is the constraint? It's really that all the data is really connected to a time and length stamping. So really, when you produce something, you have to know the history on the product itself, really when it happens on the wire. So it's not like a standard data logging, for instance, on the production line where you say it starts at 4 o'clock in the morning, it's running for 2 hours, and okay, you know the history under 2 hours. You want to know what happens at a certain time, really under certain lengths. And that's if really you interconnect all the devices in the factory. That's a capability that we have, is really to trace and connect the things. Because the origin of this product is, of course, customers said, you have test devices, let's network them. That's fine. Then came, there are some other devices in the market, or we need other test capabilities in our factory. So let's network them as well. What we did, and then came the production machinery, extrusion lines, brake machines, whatever. So continuous production floors, and this was then also interconnected with our system. And that, when really you can integrate a complete factory, say from entry control till final product, then of course you have the full traceability upwards, downwards. So if at the final testing you see that there's a problem, you can go back and see whether, okay, what was the origin of the problem, and see if it's a problem with raw material, for instance. Okay, what do I have still something in stock which I should maybe not deliver, and make the needed corrections, or reproduce, or re-engineer or reproduce the product in a correct way. So in fact, our system is a bit the missing gap. You have the ERP, who is managing the overall company. Then you have production management, or production planning rather. And then you have the shop floor and what is in between. And that's where our system can be used. So the ERP handles all the commercial and technical data. The MES, everything which is connected to operations, planning, and so forth. And it is blocked. Yeah. Then the CIQ handles the quality data. So this is coming from several places. It can come from production line. It can come from intermediate testing. It can come from final testing, different laboratories. So there are a lot of quality data available in the factory, but very often in different, we call it quality islands. So each testing facility has a certain amount of data, has a certain format of that data, and in fact we have to be able to use it in a way that it's comparable and that we can use this data. Quite often when we visit our customers, they all say, we have a lot of data, we don't need your system. And the data is there, that's for sure, but is it usable? And that's what is really very often missing. Yeah, in the end you have the ERP, to which our system can be connected. So it handles the commercial, technical data. We connect the quality islands, and we put everything in a data warehouse. What is a bit specific to our system is that we're not only grabbing information from test devices, so I would say one-shot tests, but we can do that also from a continuous production system, so say extrusion lines, for instance. So we have for that a module that we call soft DLC. So the ERP is providing commercial technical data to our system. Based on that, we can define certain test plans. We can even provide for, I would say, low-end machineries or machines which have not a very dedicated production supervision system. We can even provide setup data and other information. So we download it to the computer which is on the production line. The system gives back to So the soft DLC is providing back to our quality system consumption, alarms, all type of OEE informations. Then you have all the inspections, the tests, and you can provide then to the ERP certificates, statistics, everything which is connected. So really it's interconnected through length and time information. And then produce a certain amount of documents and data which can be used afterwards, thanks to different tools. So basically we have this QDM, quality data management, where we have the test plans, test orders. Really the idea is that the operator is really guided, and we define really beforehand what is going to be tested, in which order, and in which frame, do as much as what is needed, but not more than needed. Then we manage the data. Then beside that, we have the soft DLC, and then we have certain add-ons which are specially designed for the cable industry. For instance, we have for all the flexible cables in elevators, for instance, and in robotic applications, you have these systems, these drag chain systems to fatigue and bend the cable and check really what is the performance of the cable after a certain amount of bendings until the cable is destroyed. So in fact, we can drive these test devices, give how many cycles are needed between each test, what is the acceleration ratio when you are bending the cable. So there are a lot of different modules that we can add to our system to guide the operator and to guide the test devices. We have also certain modules in order to help the operator in the laboratory, because of course you have certain simple tests that you do in the laboratory, or for instance if you have a cable which has a certain failure, you can maybe repair it, but you want to make sure when you repair it that it has been repaired. So we provide this facility so that the operator is really guided and that in the end you have the correct cable or that you have a correct product for the purpose that has to be delivered. The CIQ is an open system. We have a lot of different interfaces. When we speak about production lines, they are very old-fashioned production lines where you have even no digitalization. You have latest systems with OPC interfaces. So you can have a huge variance of devices within the factory. So either we make the interfacing or we guide the customer to make the interfacing so that then we can pull all the needed informations for our system. You might ask, yeah, but in fact you are selling test devices, so you want the customer to use your test devices. Yeah, of course we do want that, but we have also some customers who are using our system and have not a single test device from us. So it's really an independent product. The dream is really that when we take it from the product perspective, is really to say, okay, we have a cable design, somebody engineers a cable, we produce this cable, so we can acquire the needed data during the production, make some tests, intermediate, final tests, and of course we give information back to the MES. But then the target would be really to close the loop. If there's a failure, is it in the cable design? Do I have to change something in the production process? And that's something where we're not yet there. But I would say that's the final target, really to close the loop. I design something, I produce it. Is it good? Is it bad? What has to be changed? Or where can I narrow the tolerances so that in fact I am going to make less scrap or make more money because my raw material consumption is being reduced. So that means also that we have to have this full traceability, and that's quite funny when we discussed about yesterday about this product passport, or I don't remember exactly the name, but in fact we want to trace a product between production to end of life, and we're not able to trace really what happens even in the factory. So it will be interesting to see how we can match the both things. Of course, we provide certain tools also for evaluation of the data. For instance, okay, that's transmission parameters of telecommunication cables, so we can monitor really in details what are the performance, or we can make quality cockpits. We can really adapt the software in very different ways, and export also the data in very many different formats, or give certain reports so that the operator and the user can provide internally documents, or you can also document quality information for your end customer. You provide the drum and you provide the test document demonstrating that you have produced a correct product. Oops, I go the wrong way. Idea also is to have a data warehouse. So we have our own database where we don't want too much the customer to put his finger in. So in fact, if he wants, he can read, we can always read data, but if he wants to read and write, we make a kind of, I wouldn't call it totally mirror, but in fact it's a kind of mirror of certain defined data. So that's the green box where in fact we copy what might be needed for future use of by the customer, and he can play then with this data. He can write, he can do whatever he wants there, and that's also security for. We spoke about cyber security also. Nobody can write here. We export, and then if you want to write, you can play with that part there, or even push it further in the cloud or in different kind of tools like Excel, QStat, or whatever. So, short conclusion. So what are the needs really? Is to trace and understand what happens during production. So it seems evident that you do that in your factory, but it's not so evident to find that everywhere. And also very important is that we speak about measuring lengths, or something which is really connected to our cable industry, and not measuring quantities. And really, when you have a final cable, is being able, if you have a mistake at the final cable, understanding each of the elements which is composing that cable, where the mistake happened during the production process. Our system supports also for when you speak about quality, about continuous improvement processes. So that's, of course, that's basics, but not always the case. We have to interconnect with, it helps us to interconnect data generated by different devices. So we don't want to have quality islands which are just separated from other systems which are generating data. So really all the systems have to be able to interchange data, and we are able to compare data. So that means also that we have to have systems which are allowed to communicate between ERP, MES, and other tools. So really the value today is really to gather continuous process data, that's one thing, and then consolidate on the other side normally quality measured parameters generated by, I would say, fixed test instruments, which are not directly related to production processes, but which are related to an individual testing, one-time test. I take my cable, I test it, is it good, is it bad, or what is a certain moment, a certain parameter that has to be tested. And really the target would be to have a full backwards and forward traceability based on the formatting which is um, based on the formatting which fits our industry. So what we want really is to produce a tool, or to have a tool, or we propose a tool which helps to support manufacturing, quality management, continuous improvement process, and makes a lot of data available then to feed AI tools or other tools which are needing a lot of data. So don't waste data, but use it. So that's in a few words what CIQ stands for and what we can propose on our side in order to clean a bit sometimes the mess in some data management systems. Any questions?
So if we have requirements for like length-based testing, so our operators should test every 700 meters a certain test.
Mm-hmm.
Is this DLC the tool to use to notify the operator that the test should be performed?
If the operator is to do it manually, then you don't need that, because that's really under the soft DLC is a tool really for continuous production process. But you can tell the CIQ that, say, after 100 meters, that the operator gets an alarm saying, okay, look, please do now your testing. So I think the soft DLC would be an overkill in that case.
Yeah, overkill maybe, but we lack that functionality.
Mm-hmm.
At some point.
Okay, yeah. But we can discuss about that. Yeah.
Okay.
Other question? Okay. Thank you.